So AutoML tables is a tool for it's almost fully automated in terms of being able to have all of those features of your ML machine learning steps being fully automated for you. So things like feature engineering, hyperparameter tuning, all of that stuff is handled for you behind the scenes by Google AutoML tables.
So today we're going to talk about AutoML tables with BigQuery. Jared, let's take a little deep dive into AutoML tables with BigQuery. Curious to see kind of what are good use cases for it? How does it work? How easy is it really to use? How auto is it? So let's just maybe dig in a little bit and talk about maybe first, like what is AutoML tables and what are some good use cases for it? Where does it fit?
Yeah, so AutoML tables is a tool for it's almost fully automated in terms of being able to have all of those features of your ML machine learning steps being fully automated for you. So things like feature engineering, hyperparameter tuning, all of that stuff is handled for you behind the scenes by Google AutoML tables. And all you have to do really is essentially point the UI at a particular BigQuery table in order to do that.
Yeah, I don't know if you're able to show a little. Let's dig in and take a look at how it works.
Yeah, let's jump in and show AutoML tables.
What do you got here? Looks like some data. How do we use this?
Yeah, so from the Google GCP hamburger stack, they call it, right on the tables UI, you have the option of data sets and models. And data sets is where you import your data and you give it a reference. In this case, we're using a public data set for fraud detection. And it efficiently reads your data using the underlying BigQuery storage API, which reads data a lot faster than if you're using, for example, the Python API. So in this case, this particular data set has a lot of features in it that are abstracted away from what the actual variables are, just because this is a very sensitive data set with some PII in it. So the curators of this data set didn't want people utilizing this in order to see PII data. So it's not important for us, but just know that there are actual features behind the scenes here. But they're all represented as variable 1 through 20 something. But in the UI, so once we import our data, it gives you a nice summary of, we have 31 columns, 284,000 rows. It gives you a breakdown of the numeric versus the categorical features. In our case, that one categorical feature is our target column that we specify up here. It's our class. So the class is whether or not the transaction was fraud or not. It's a really highly imbalanced class. So in machine learning terms, that means that there's very few fraudulent transactions out there as compared to all of the other valid transactions out there. And then right out of the box, without having to do anything, AutoML tables gives you this really nice breakdown showing you whether the feature is nullable or not, the data type of the column, the percent that are missing, as well as invalid, the distinct values. So this is helpful for understanding if features, if you only have a few features that don't vary very much, you might want to consider not including that into your model. And then you also have the correlation with target right down here. So this shows the degree to which how correlated the input feature is to the target that you specify. So right out of the gate, this takes a lot of the legwork out of your typical ML workflow by just breaking down all of these features here for you. So this is all before I've even trained the model. So if I go and click on train model, it'll give you a budget. So this is basically, you enter in the amount of node hours you want AutoML tables to spend trying to optimize and find the best model. So once you provide that and you select your features that are in your model, you click train model, it'll run for several hours, and then it'll give you an email notification once your model is ready. In this case, I've already trained this model, so we don't have to go through that. But so it'll give you, this is the basic summary of what you're provided once your model is done training. So it provides you things like the area under the precision recall curve, your accuracy, and your log loss. And then we could click on this to see further breakdown of how the model performed.
So what do you think about this? Does it look pretty good?
It does look pretty good, yes. Although this is a highly imbalanced data set, so you have to judge it in terms of how well or how balanced the data set is. So the results look good, but it's also somewhat deceiving because in the raw data, there's only a very few level of fraudulent transactions. So we could get a very accurate model simply by just guessing that every single transaction was non-fraudulent. So you have to always judge it on that baseline of how balanced your data set is.
Sure. So it does a lot for you, but you still need to understand a little bit about what you're trying to do and what the outcomes are going to be, right?
Yeah, exactly. Some cool features in this is this gives you this slider for the score threshold. Your score threshold is your value of your prediction result and then what the model will predict is the class. So let's say that we have it set to 0.53 now. Any prediction value above 0.53 is going to be a prediction of fraudulent, and anything below that is going to be non-fraudulent. Well, maybe we want to be able to customize this and set the threshold value to anything we want. We can do that in the UI here using this tool, and it'll update your results in real time as you move this slider back and forth.
Yeah, what next? So now we want to use this in our, maybe an application or just, somebody wants to go use it to query some data. Like how do you then leverage this to take this to production?
Yeah, so the next thing I would say is you have your chart here of your feature importance. Maybe you want to go back and retrain your model after removing a lot of these features that aren't as important. Your variable 15 came in as the most important by far. So maybe you want to go back and retrain this model to remove some of those non-important features. But otherwise, if you're good to go with your model and you want to just use it, there's several ways you can use your model. You can generate a batch prediction. So that's basically what you want to do if you want to just point your model at a new data set in BigQuery and you want to get predictions on that data. So let's say you have a whole new day's worth of transactions that you want to get predictions for. Here's where you would come in and do that. You can also get online predictions, which will be a little bit more expensive, but that will allow you to get predictions in real time. So you can see in this particular use case, when you're trying to, at the point of sale, you're trying to predict whether or not a transaction is fraudulent or not. This will be really valuable to have this available in real time. And then you can also export your model. Let's say you want to be able to serve your model locally on a device. This is where you can go and do that.
Yeah, or however you do your model hosting today, right? So you can export this TensorFlow and run it anywhere you want to, right? So you can run it in your own container, VMs, kind of whatever works for you, right?
Yep.
That's awesome. Thanks for the overview.
Yeah.